Hey guys, so I have the assignment here from today, from February 3rd. I have my doc cam up and the assignment, so just gonna go through it here on a blank sheet of paper. So transforming, so this concept of transforming, it means to move the graph in a specific way. A transformation would be something specific, like the graph might just slide up or down, right? So I'll just use kind of a line as my example. So a line, if it just slides up or down, or if it just slides to the right or to the left, that's called a translation, okay? Eventually you might need to know these words. If the graph flips, right, if it flips either over the y-axis, right, it's kind of hard to show, but if it flips over the y-axis, it's doing something like a left or rightward flip. If it flips over the x-axis, it would be doing like a downward flip, or maybe upward flip. So that's called a reflection. If it flips, it's called a reflection, and it could flip to the side, or it could flip, vertically or horizontally. It's called a reflection. And a vertical flip would technically be like over the x-axis, while a horizontal flip would be over the y-axis. And then that's really all you need to know about for now, so we'll leave it at that. And then we have number 1 here. Answer each without using Desmos. Well, you definitely can show some work to do this, but eventually the point here is that you would know. How would the graph of y equals negative 3 to the x power be different from y equals 3 to the x power? So all that's different here is, right, it's y equals 3 to the x, and the difference is this one is y equals negative 3 to the x, and we saw in the Desmos that if all you do is change the sign of the base, that's going to be a flip down over the x-axis. So changing the base to, right, or should we say changing the base from 3 to negative 3 will make the graph, it'll flip down over the x-axis. That is aka a reflection over the x-axis. We'll make the graph reflect over the x-axis, okay? And again, if you go back to the Desmos, you can kind of verify that. If you go into Desmos and just graph these two things, you can also verify that. Let me see here. So I just opened Desmos real quick just to show you. So if I type in y equals 3 to the 3 to the x power, you can see it graphs it here. And if I go to my next step and I type in y equals negative 3 to the x power, I can show you that that's actually going to happen. I did say it was going to flip over the x-axis. Well, here you can go into Desmos and verify that. Again, changing the 3 to a negative 3 and leaving everything else the same, you can see the graph basically flips downward. The red, you can see the red is this 3 to the x power. The blue is negative 3 to the x power. And again, changing the 3 to a negative 3 is a reflection over the x-axis. So from now on, when I'm explaining what the graph's going to do, just know you could come in Desmos and see what that looks like. Alright guys, so carrying on number 2, how would the graph of y equals 2 times 0.45 to the x power minus 5 be different from the graph of y equals 2 times 0.45 to the x power? Well, first of all, if you got to recognize what's different. These two equations are identical other than this minus 5. This one over here, 2 times 0.45 to the x, and this one also is 2 times 0.45 to the x, but it also has a minus 5. So how's the minus 5 going to change that, right? The minus 5 will translate. Remember, translate means slide, so translate aka slide, right? The minus 5 will translate the graph 5 units down. That should make sense, right? Minus 5 would be logical to move down, not up, right? If it was positive 5, it'll move up. Minus 5 will move it down. Again, that is a slide down, aka a translation. Translate is a slide. Number 3, how would the graph of y equals negative 8 times 39 to the negative x plus 1 be different from the graph of y equals negative 8 times 39 to the x? So this one is a little bit of a pain because it's two things that are different. This one over here, the exponent is a positive x. So over here, the exponent is a negative x. That will change things, right? So up here, if you look back at number 1, the positive 3 is different because this is a negative 3. And up at number 1, remember it made the graph reflect over the x-axis. Well, when you change the exponent from an x to a negative x, it's not going to flip over the x-axis anymore. It's going to flip over the y-axis. Let me say that again. Changing the base from positive to negative, from a positive 3 or negative 3, reflects over the x-axis. But if you change the exponent from a positive x to a negative x, it'll flip over the y-axis, a reflection over the y-axis. And you can punch these into Desmos to see what that looks like. But either way, the exponent going from positive to negative, right? So let's say x changing from positive to negative will cause a reflection over the y-axis, and then that plus 1, as you may guess, right? But how's the plus 1 going to change it? Because not only does the x change from positive to negative, it also has a plus 1 that this one doesn't have. So the plus 1, right, and the plus 1 will slide the graph or translate the graph up one space. We'll slide the graph up one space. So there's that. Moving along to number 4, match each equation to its correct graph. The original parent function is y equals 4 times 2 to the x power. Okay, guys, so original 4 times 2 to the x. This number 4 has, instead of having a positive 4, it has a negative 4. Remember, that is going to be a reflection over the x-axis. Changing that 4 to a negative again will reflect over the x, which makes it C. Yeah, because originally the graph would, if you follow my mouse, the original graph does this. So reflecting that over the x-axis will result in C. So number 4 is C, and you can kind of check that. You could punch into Desmos y equals 4 times 2 to the x power, and then y equals negative 4 times 2 to the x, and it will definitely flip down. Number 5, oops, sorry about that. These are just letter answers. Number 5 is 4 times 2 to the negative x, as we just talked about in number 3. Changing the x to a negative x will flip the graph over the y-axis. So again, based on what the original graph does, it looks like B is our answer for this. When you change the x to a negative x, the graph would flip over the y-axis, and it would result in what you have here in answer choice B. Again, punch it into Desmos if you want to kind of see it. Oh wait, that's not C, that's 6. And then 6, y equals 4 times 2 to the x minus 3. Well, the original graph would shift down 3 spaces. So it's here. Well, it's a little weird the way it's showing the minus 3, but it's shifted down 3 spaces. So these must be going by 2s. It goes 2, 4, 6, so that's 2, 3 spaces down. Number 6 is definitely A. Of course, by process of elimination, but also because the minus 3 is going to shift the original graph 3 spaces down. Number 7, you start with 2 pencils. This is kind of just review here. It's no longer transformations. You start with 2 pencils. Every day you buy 5 more pencils. Linear or exponential. So number 7, right? Number 7 is, first of all, you're buying 5 more each day, so plus 5 each day. Not only is that my slope m, but the plus 5 each day is a constant being added every day, which makes it linear, okay? So the plus 5, not only is it adding 5 each day that tells me it's linear, but it's also my slope m. The initial value is what you start with. It said you start with 2 pencils, so 2 is initial value, aka the y-intercept, b, and then the equation, well, guys, once I know it's linear, I have to use y equals mx plus b. If it was exponential, I'd be using y equals a times b to the x power. So again, m is your slope, goes here, b is your y-intercept, it goes here, so the equation for this one is y equals 5x plus 2. Okay, and then you have your, it's linear because it's adding the same amount each time. Number 8 is, well, just look at the outputs, right? The inputs are all, well, they're kind of in order. Look, -1, 0, 1, 2, but then 4 and 6 are out of order. So, so I'm only able to use these first few to check. Let's see, 2, 6, 18. I think I know what's happening. Multiplying by 3. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. 54 times 3 is not 486, but it's missing the 3 here, and it's missing the 5. So anyhow, this is definitely exponential. It's exponential because times 3 to get consecutive outputs, right? The constant multiplying by 3 tells me it's exponential. And then, and remember the initial value is where x is 0, the initial value is 6, so a is 6. And again, guys, once I know it's exponential, I also know it's this equation, y equals a times b to the x power, where a is the initial value and b is the constant multiplier, the multiplicative rate of change. So a is 6, b is 3, so the equation for this one is y equals 6 times 3 to the x power. And again, you can kind of verify that in Desmos if you wanted to, that 6 times 3 to the 0 power is 6, 6 times 3 to the first power is 18, 6 times 3 to the second power is 54, and so on. So again, there's your answer, your equation. So moving right along here, guys, number 9, you start with $2 every day. The amount in the count triples, guys. Triple means times 3, okay? So number 9, again, tripling means times 3, since it's multiplying by 3 each day, right? So it's exponential. Times 3, it's definitely exponential. And then the initial value, well, you started with $2, so $2 is your initial value, okay? And again, since it's exponential, it's definitely y equals a times b to the x, where a is the initial value and b is the multiplier, the multiplicative rate of change. So it's 2 times 3 to the x power. Again, if you go into Desmos, you can kind of see what the graph looks like. You can verify that the account will go, on the first day it'll go to 6, and then in the second day it'll go to 18. Again, it's tripling, okay? Exponential because it's multiplying. And then this last one, let's see, -2, -1, 0, 1, and then it skips to 5 and 12. So I can only use these first 4 as consecutive. Once it skips from 1 to 5, it's no longer consecutive. Let's see, -10, -7, -4, -1. I think I know what's happening, guys. It's adding 3, because -10 plus 3 is -7. -7 plus 3 is -4. -4 plus 3 is -1, and then -1 plus 3 is 2, right? And then 2 plus 3 is 5, and then 5 plus 3 is 8, and 8 plus 3 finally would get me to 11, but it does skip the values for 2, 3, and 4. So again, it's adding 3 each time. That makes it linear. Plus 3, so linear, right? Once I know it's linear, I know to use the equation y equals mx plus b, and in the equation y equals mx plus b, the rate of change is m, so it's y equals 3x plus the initial value, 3x, and then remember the initial value is found where x is 0. Where x is 0, y is -4, so there's your equation. It's linear, and it's y equals 3x minus 4. Hope this helps, guys. Thanks for having a look.